Hello students. See what is today's NEET reaction, that is Claisen condensation, my dears. Observe careful. According to JEE point of view, this is very important as well as NEET also, my dears. So be focused. See, first of all, the definition. See, what about the definition? See here the definition of Claisen condensation. Esters having alpha hydrogens on treatment with strong base. Example C2H5O minus Na plus. Today NEET reaction. What is the NEET reaction actually? See, the Claisen condensation we'll discuss. This is very important according to JEE point of view, my dears. So be focused here. Esters, the Claisen condensation definition. See here, first of all, esters having alpha hydrogens on treatment with strong base. Example C2H5O minus Na plus undergo self condensation to produce the beta keto ester. See sir, what is this definition, sir? What is this definition? Sir, the definition is listen and forget, right? It is not very important, my dears. So what is that important? Actually, the mechanism and reaction and applications is very important. So if you want to take down this definition, my dears. Esters having alpha hydrogen on treatment with strong base. Example C2H5O minus Na plus undergo self condensation to produce beta keto ester. See, my dears, the definition is not important, right? What is that important? That is reaction and mechanism and application, my dears. Please take down. See, esters having alpha hydrogens on treatment with strong base. Example C2H5O minus Na plus undergo self condensation. Here the 2 points are important. What is the 2 points? See, alpha hydrogen and beta keto ester. See sir, these two terms I can explain, right? Listen careful. This is 2 terms is very important. So shall I wrap? If you want to take down, otherwise skip, right? See, my dears. See, first of all, mechanism is very reaction. That is, I'm taking here 2 molecules of ester, right? In presence of strong base, that is C2H5O minus Na plus. In acidic medium, this is 1, this is 2. 2 molecules of ester in presence of base in acidic medium. So what is the product? Product is CH3, C double bond, CH2, C double bond, C2H5. This is a reaction, my dears. This is reaction, very important, my dears. Right. Now see what about the mechanism? The mechanism is very important, my dears. Be focused here. Let's begin our mechanism, my dears. See, MEC stands for what? MEC stands for mechanism. The first step, CH3, right? For our convenience sake, I have written like this: CH3, C double bond, O, C2H5, right? Added strong base, that is C2H5, O minus. Now observe careful, observe careful, observe careful, observe careful, right? See here, the first of all, what happens? Here, the heterolytic cleavage takes place. It gets negative charge, it gets positive charge, right? Carbon gets negative charge, hydrogen gets positive charge. So what is the reason, sir? The reason, the simple reason, my dears, why? Because see, the carbon electronegativity is more than the hydrogen, so that is the reason electrons pulls towards the carbon side, that's all. So this carbon gets negative charge. Now what happens? This base abstract the proton, right? Abstract the proton. Now C2H5 OH will form, right? One negative, one positive becomes one bond, my dears. Negative, one positive becomes one bond, that's all. Now see, what is the next step? CH2 minus C double bond O C2H5. H5. This is what? Carbanion. Right? It is carbanion. This is very, very powerful nucleophile, my dears. Powerful nucleophile. Actually, see, my dears, here the carbanion are unstable, right? But here this carbanion is very stable. So what is the reason, sir? The reason is that, observe careful, my dears, here the heterolytic cleavage takes place, negative positive, it will becomes here. See, this carbanion participate in resonance. This carbanion is participate in resonance. So that is the reason. It is stable carbanion. Stable carbanion, right? Now see, the second step. Second step is CH3 C double bond O C2H5. This is what, my dear? Powerful nucleophile. Powerful nucleophile. Right? Now see what happens. Observe careful. Very easy, my dears. See, first heterolytic cleavage takes place. It gets negative charge. Carbon gets positive charge. Carbon gets positive charge. Now this negative charge will attack it here. See, one negative, one positive becomes what? One bond. That's all. Here I will write here. Take down this point. Very important point. Important. Please, my dears, be focused. Take down this point. One negative charge. One negative charge. And one positive charge. Positive charge becomes what? One bond. One bond. Please, my dears, this is very important. So, my dear students, please take down this. Don't neglect this. Don't neglect this. Right. See, what I want to say that here the one negative, one positive charge becomes what? One bond. That's all. That's all. Right. So, shall I up? Okay. Pause and take. See, my dears. Now here, one negative, one positive becomes one bond. Right. See here, CH3 O minus OC2H5. See, sir, this OC2H5 I have written here, sir. Don't confuse. Right. Now this CH2, this carbon I'm writing here, CH2, C double bond, O, C2, H5. H5. Now observe carefully here. This is very, very important step. Here, the first, this bond will breaks. Heterolytic cleavage takes place. It gets negative charge, carbon gets positive charge. Carbon gets positive charge. So what is the reason to break this bond, sir? The reason is that due to plus R effect. Take down here. Due to plus R effect. Due to plus R effect. See, sir, what it means of plus R effect, I can explain you. Please be focused. Here, just remember, just listen my ideas. This negative charge pulls towards this carbon side. So what happens? This carbon gets more negative. So that is the reason this bond will breaks. That's all. That's all, my dear. That's all, right? So next, this is called as what? Oxonium ion. What? Oxonium ion. Oxonium ion, need not to remember this name, just listen and forget. Now see, the third step, see my dears. Third step, see, here, third step, here lost C2, HF5, O minus. Now, one negative, one positive becomes one bond. One negative, one positive becomes one bond. One negative, one positive becomes one bond. See, my dear students, if adjacent carbon, it's adjacent carbons or adjacent atom, one negative, one positive charge there, means it becomes a what? One bond, my dear. It becomes a one bond. That's all. See, suppose, think that this is one atom. This is one atom. Right, this atom has negative charge, this atom has negative charge, this atom has positive charge. So what happens if adjacent beside there, so it makes one bond, that's all, my dears, right? So if adjacent there, so it makes one bond. So what is the product will form? CH3, C double bond, right? CH2, C double bond, O, C2, H5. See, my dears, this is beta keto ester. This is beta keto ester. So why it is called as beta keto ester? Be focused. Observe carefully here, my dear. See, this is what? Functional group, right? Ester functional group, right? Functional group beside carbon is alpha carbon, right? Alpha carbon beside carbon is what? Beta carbon, right? Now observe careful, my dears. Here the beta carbon contains what? Keto group. So that is the reason this is called as beta keto ester. Listen, my dears, once again I repeat. Here, this is the functional group, that is ester. Ester beside carbon is alpha carbon beside carbon is beta carbon. Beta carbon contains what, my dear? Double bond. So that is the reason this is called as what? Beta keto ester. Beta keto ester. So beta keto ester. So, my dears, so this is a mechanism. Please take down this. Right. Shall I up? Right. Now, applications is very important, my dears. Application is very, very important. See here, first application. Application. See, sir, in JEE mains, applications will ask. So be focused. One second. See my dears, this is reaction, rearrangement and reagents. Essential. Who's essential? This book is very useful for JEE mains as well as JEE advanced also, my dear. JEE advanced point of view, this book is very important. Please purchase, my dears. So for who? Please purchase any circumstances. Essential, right? In that book, what it will be, the lot of applications are there. So that is the reason. Please, my dear, humble request, purchase in any circumstances, right? Now let's begin our first application. See here, the first application. First application. Right, OC2H5, right, CH3, CH2, C double bond, OC2H5, in presence of strong base, my dear, that is C2H5O minus Na plus and acidic medium. My dear students, here I have written base, right? That is C2H5O minus Na plus, right? Now see, observe careful. This is what? Functional group, right? Functional group beside carbon is alpha carbon, right? Alpha carbon contains alpha hydrogen. So this base abstract the proton from alpha carbon. So what happened, my dears? What happened? It gets negative charge, right? Carbon ion gets negative charge. So next step is see, electrolytic cleavage takes place. This gets negative charge, carbon gets positive charge. Here, this carbon ion attacks at positive site, negative, one positive becomes one bond. See sir, this H plus will abstract the proton, sir. Otherwise I will write. See here. Electrolytic cleavage takes place. This H plus abstract the proton. Right? Right. So for understand sake I said, right? Right? This abstract the proton. Right. See my dears, this base abstract the proton from alpha carbon. So that is the reason alpha carbon gets negative charge. Now this negative charge will attack at positive site. So what happens? The product will double bond C double bond, O minus OC2 HFI CH2 CH, CH3, C double bond, O, C2, H5. See, just observe careful. This carbon ion, this alpha carbon has two hydrogens, alpha hydrogens. One alpha hydrogen abstract the base. So that is the reason this carbon gets negative charge. Now this carbon ion is attacks at this positive site, so it becomes one bond. See sir, this carbon and this carbon, and this carbon. Now here what happens? This bond will be breaks, right? It gets negative charge, it gets positive charge. right? Due to plus R effect. Due to plus R effect. Observe careful. Here, one negative, one positive becomes one bond, my dears. CH, CH3, C double bond, O, C2, H5. C2, H5. Right? So, this is first application, my dear. First application. Now, the second application. Please take down. The second application. HC double bond O C2H5 plus CH3 C double bond O C2H5 added base and in acidic medium. What happened, my dears? This base abstract the proton from alpha carbon. This base abstract the hydrogen from alpha carbon, right? Now, see what happens. This gets negative charge. This gets negative charge. Now, heterolytic cleavage takes place. It gets negative charge. It gets positive charge. Now, this negative charge attacks it here. One negative, one positive becomes what? One bond, right? One bond. See, sir. HC double, sorry, not double bond, O minus, here O C2 H5, CH2, C double bond, O C2 H5. See, sir, here I have written CH2, sir. Here CH3 there, sir. Sir, this base abstract the 1H plus, so that is the reason I have written only CH2, right? Now, due to plus R effect, it gets negative charge, carbon gets positive charge. See, observe careful, my dear, observe careful. Once again, please be focused. Here, in this step is very, very important step, my dear, right? See, what happens actually, due to plus R effect, this bond will cleavage takes place. Due to plus R effect, this bond will cleavage takes place. Point number 1. Right? Point number 2. See, this oxygen gets negative charge, this carbon gets positive charge. Sir, what is the reason, sir? What is the reason to get oxygen get negative charge? So why? Because oxygen has more electronegativity than the carbon. So that is the reason. If heterolytic cleavage takes place, oxygen gets negative charge, carbon gets positive charge. That's all, my dear. That's all. Now, observe carefully. The CH, sorry, not nice. Right. Double bond. Oh, CH2. C double bond, O C2 H5. So that is beta keto ester, sir. That is also beta keto ester, right? The second application, please take down. Right. Now third application, see, my dear. Third application is very, very important, my dear. Very, very important. Right here. The intramolecular Claisen condensation. This is for advanced. This is very, very important, my dears. Be focused. Here, see here. O C2H5 CH2 C double bond O C2H5. Now see, intramolecular Claisen condensation. It is also called as Deichmann reaction. My dears, be focused, please. Right. So what I added, sir? Base, sir. Base I added, right? Not I added, Claisen added, right? Base added in acidic medium, right? So what happens? The base abstracts the proton from alpha carbon, right? Alpha carbon. So from alpha carbon, see here, observe careful my dears, this is functional group, clear, right? Functional group beside carbon is what? Alpha carbon. Alpha carbon contains alpha hydrogen. Sir, this base abstract the alpha hydrogen, sir. Alpha hydrogen, sir. That's all, sir. For our convenience sake, I am writing like this. 1H, right? Now what happened? The heterolytic cleavage takes place. This carbon gets negative charge. This hydrogen gets positive charge. This hydrogen gets positive charge. Now this base abstract the H plus. Sir, actually what is that base, sir? Actually that base is C2H5O minus, sir. So this C2H5O minus abstract this H plus. So that is the reason what happened, C2H5OH will form. Leave, right? C2H5OH will leave, right? So next step, see my dears. Next step is very, very important step. Heterolytic cleavage takes place. It gets negative charge. Carbon gets positive charge. Carbon gets positive charge. Carbon gets positive charge. See here, now observe careful my dears. Observe careful. Observe careful. Here, this negative attacks at positive site. This negative attacks at positive site. One negative, one positive becomes one bond. My dear students, see how many times I am repeating this word, because this is very, very, very important, my dears. See, one negative, one positive becomes what? One bond. One bond. So here, finally, O minus, right? See, this is new bond, right? C double bond, O, C2, H5. This is O, C2H5. Now see my dears, observe carefully. Now, this bond will be breaks. It gets negative charge, this gets positive charge. See, otherwise I will write once again, my dear, for clearly I will write. See here. C2H5. Alright. Now see, this heterolytic cleavage takes place. It gets negative charge. See my dears. See, heterolytic cleavage takes place. So, see my dears, heterolytic cleavage takes place. So, that is the reason this gets negative charge. This gets positive charge. Now here, one negative, one positive, one negative, one positive becomes one bond. So what is the reason, sir? What is the reason to break this bond, sir? Due to plus R effect. So one negative, one positive becomes what? One bond. That's all. One bond. See, sir, this is intramolecular Claisen condensation, also called as what? Dykman reaction, my dears. So this is the reaction and mechanism, my dear students. Be focused, and in any circumstances, if it is possibility there, so purchase this book, right? SN Sanyal, and please stay home if you can. Please stay home if you can. So this is yours, Ravish. Take care. Bye-bye.